Learner's Choice. Today we are going to discuss propositional logic. So what is proposition? First we should know the definition of proposition first. What is proposition? So proposition is a statement, that is declarative statement. That statement is either true or false. Sometimes it is true or sometimes it is false, but we don't bother, either it is true or false, but that statement, declarative statement, is a proposition. Okay, for example, the car is in white color and the another one is today is Monday. So these are the statements, that is declarative statements. Either the value is true or false, but we may not know the value. So this is proposition. And there are some important laws of proposition are there. The first one is law of contradiction. What is law of contradiction? The value is not true means automatically it is false. We know the thing very well. Suppose if a thing is not true means automatically that thing is false. Okay. If sometimes something is not true, then it has to be false. So here that till sign is not sign. Suppose something is not true means automatically it is false. So false is equal to not true. And similarly, something is false means, sometimes something is false means, that is not false means, automatically it has to be true. So true is equal to not false. So this is the law of contradiction. Okay, and second one is law of excluded middle. So what is law of excluded middle? Here no middle position is possible. Suppose you can take a statement and that statement is either true or false, but it cannot both at the same time. At a time that statement is either true or at some point of time it is false. Both true or false are not at the same time. That is called law of excluded middle. Now we discuss some important signs of propositional logic, that is and, or, not, implies and bidirectional. So what is and? It is conjunction, and or is disjunction, and not implies bidirectional. So already these concepts are very same in digital logic, as we already know that very well. So the same signs are also used here in propositional logic, and the first one is conjunction. So what is that? Is and sign. Here we are going to use the and sign. So in that conjunction truth table, we have to take two variables P and Q. So P and Q. So suppose we have to supply values for P and Q. The first value, that is both are false, means automatically P and Q are false. So false and true means it is false, and true and false means false. Both the values are true means the resultant value is also true. So this is conjunction. So next one is disjunction. So in the case of disjunction, it is or sign. We have to take the or, that is plus. Here we have to add the values. So here we supply the values for P and Q. So in the first case, both the values are false. So false plus false, that is 0 plus 0 is equal to 0. Then 0 plus 1, that is 1. 1 plus 0, that is 1. Then 1 plus 1, that is also 1. That is false. False and false are false. False and true is true. And true or false is equal to true, and true or true is equal to true. So this is the disjunction, that is this is the truth table of or. Next one is implies. In the case of implies, we should concentrate little more of implies truth table. Here we have to take two variables, that is P and Q. The implies means P implies Q. This means suppose we have to take the first two values are false means the resultant value is true. Now we just that is, for example, we take P is the that is reading. P is reading and Q is writing. So writing and reading both are the part of the learning process. So we just take an example for the learning purpose. Reading and writing both are the part of the learning process. So now the first value, reading, that is P, is false. That is we cannot read something and we cannot write something in the examination. There is no learning process. So that statement is true. So reading and both writing are not done properly, then the resultant is not properly done. That is, learning is not there. So that's why the first statement is true. We should very clear about it, then only we can study the concepts very well. That is, suppose if you read something and then you can write something in the examination, then only the learning process is done properly. So the first case, both the conditions are false, means the learning process is not there, so that it is true. And similarly, in the case of reading, it is false, but in the writing side, that is writing examination, means you can also a part of the learning process, so that it is true. Suppose you are not reading, but you write something in the examination, so that is also the part of the learning process, so that it is true. So in the second case, the first part is false, but the second part is true, means automatically it is true. And similarly, the another one is reading. Reading is true, okay, but the writing part is not true. Suppose you are not write your examination, but you read something, but you are not write in the examination. Is there is any resultant that is in the learning process is not completed, so that it is false. Reading is okay, but writing is not there. Writing examination is not there, so that learning process is not there. So this is true or false. True and false, it implies false. In the case of implies, it is false. And finally, you have to read something and you have to write that concept in the examination. Well, both the process are doing, both part of the learning process are done there, so that learning is also successfully done. So in the last case, both the true values gives the result true. So this is the simple trick to understand the implies truth table very well. And next one is bidirectional. So bidirectional means P implies Q as well as Q implies P, that is bidirectional. So in this case, the first two values, that is P and Q values are false, means automatically the resultant value is true. And the second values, that is in case of P is false and Q is true, means automatically it is false. And the P is true and Q is false, means it is also false. And both P and Q are true, means the resultant value is also true. So in this bidirectional, we should understand in case both the values are same, that is P and Q are same, we don't bother about whether both the values are true or false. We least bother about that, but we should remind that both the values, that is P and Q values or whatever it may be, but it should be same. Then only the result will be same. That's why the first two false values gives the result true, and last two values, that is true, will gives the result true. So it is true only when P and Q both are same. In bidirectional, the values true. So in bidirectional, we should keep in mind that the values of both P and Q, whether it is true or false, but the resultant, both the values are same, means the resultant value is true. that is bidirectional, and the negation. So automatically what is negation? Once we supply some value, that is true or false, means it will give the that is the not value. Suppose if you give true, that is 1 to p, means automatically it will become 0. Suppose if you give false, that is 0, means it will give the value 1. So this is negation. That is if it is true, means it will give false. If it is false, means it will give true. So this is negation. So these are the some important symbols and important truth tables of propositional logic.